Hi, I'm Engineer Febus Reidj Cruz from Mapua University, School of Electrical, Electronics, and Computer Engineering. I hope that you are having a great day. In this video, you will be familiar with the different types of semiconductors. The major types of semiconductors are intrinsic and extrinsic. The intrinsic are pure semiconductors, while the extrinsic are doped semiconductors. Intrinsic semiconductors behave like insulators because of the covalent bonding in the crystal structure, resulting in 8 valence atoms and a lack of charge carriers. To improve the conductivity, the intrinsic semiconductors are subjected to a doping process to become extrinsic semiconductors with altered charge carrier densities. The charge densities in N-type semiconductors are changed by introducing them to donor dopants with extra electrons, which makes the number of free electrons greater than the number of holes. The concentration of pentavalent donors dictates the density of free electrons in N-type. In P-type semiconductors, the charge densities are modified by doping them with acceptor atoms. The available holes in acceptor atoms cause the number of holes to be greater than the number of free electrons. The concentration of trivalent acceptors dictates the density of holes in P-type. Intrinsic semiconductors are made of elements with 4 valence electrons. These are elements in group 4A, although the practical semiconductors are only silicon and germanium. Carbon is more of an insulator, while tin and lead are more conductors. Compound intrinsic semiconductors are made by combining the elements from groups 3A and 5A, elements from groups 2B and 6A, or elements from groups 4A and 4A. In both elemental and compound types, the intrinsic semiconductors have 8 valence atoms in their structures due to covalent bonds. N-type semiconductors are manufactured by donor doping. Donors are group 5A elements with extra free electrons. The intrinsic dope with 5A is made to N-type. And when the N-type is further exposed to 5A, it becomes a heavily doped N-type, denoted as N+. Even the P-type can be converted to N-type with donor doping. The P-type becomes neutral, like the intrinsic, when exposed to 5A, and develops into an N-type when continuously doped with 5A. These interchanges between N-type and P-type layers are useful in the fabrication of semiconductor devices. P-type semiconductors are made by acceptor doping, which uses group 3A elements having extra holes. Intrinsic mixed with 3A becomes P-type. And when the P-type is further doped with 3A, it turns to P+, a heavily doped P-type. Also, N-type layers are changed to P-type by acceptor doping. In summary, the elemental intrinsic semiconductors are group 4A elements, and the compound intrinsic semiconductors are combinations of groups 3A and 5A, 2B and 6A, and 4A with another 4A. And the N-type extrinsic semiconductors are made by group 5A doping, while P-type extrinsic semiconductors are produced by group 3A doping. Keep going with this series on basic physics of semiconductors. And before we end this video, please allow me to encourage you to appreciate your studies and enhance your creative and innovative ideas. Thank you, and see you again in the next videos. Thank you very much.